Two point charges 2 centimeters apart have an electric potential energy of negative 180 microjoules. The total charge is 30 nanocoulombs. What are the two charges? So this problem has to do with electric potential energy, and I went ahead and I wrote out the equation over here for potential energy, where U is the electric potential energy, K is a constant, 9 times 10 to the 9th newtons times meters squared over coulomb squared. Q1 and Q2 are the charges of each object, and R is the distance between the charges. I went ahead and I did some basic conversions as well. I converted the 2 centimeters to meters, microjoules to joules, and nanocoulombs to coulombs, which we'll be using later. But going back to the electric potential energy equation, this problem in specific has to do with finding the two charges, aka Q1 and Q2. And because it's saying the total charge is 30 times 10 to the negative 9 coulombs, we can rewrite Q1 and Q2 as Q1 plus Q2 equals 30 times 10 to the negative 9 coulombs. And because we are going to have two unknowns in this equation, which is the Q1 and Q2, we have to try to get it in terms of just one unknown versus two. So in this case, I'm going to try to keep everything in terms of Q1. So I'm just going to go ahead and make Q2 equal to 30 times 10 to the negative 9 coulombs minus Q1. So going back to this equation over here, I'm just going to rearrange it so we're isolating Q1. Again, just because I'm trying to get everything in terms of Q1. So Q1 will equal U times R over K times Q2. Again, as we see here, we have two unknowns, but we only want one unknown. So we can just go ahead and plug in the Q2 equation we found over here to this Q2 over here. I'm just going to rewrite that to get So now we have everything in terms of Q1, and I'm just going to do some algebra to get everything on the left side of the equation. I'm going to multiply the denominator by Q1 and then also move the U times R to the left side of the equation as well. And after doing some algebra, we should get the following. Equal 0. From here, we have to use our quadratic equation, which is this over here. I'm going to go ahead and label this equation in terms of the values from the quadratic equation I wrote here. So I'm going to label this one, the negative Q1 squared, as A, the 30 times 10 to the negative 9 coulombs times Q1 as B, and the U times R over K as C, which we will use to plug in to the quadratic equation. So plugging everything in, we will get the following. I'm just going ahead and plugging in the values for U, R, and K. Negative 180 times 10 to the negative 6 joules will be the value of our electric potential energy, which is U. Our R value is 0.02 meters. And the K value is 9 times 10 to the 9th Newton times meter squared over coulomb squared. And this entire thing is going to be over 2 times A, which is negative 1, because the value in front of the negative Q1 is 1. So it'll just be this whole thing divided by 2 times negative 1. After we multiply this out, we should get two values for Q, one that's positive and one that's negative, which is essentially going to be our Q1 and our Q2. For the first one, the positive number, we should get 40 times 10 to the negative 9 coulombs. And for the negative number, we should get negative 10 times 10 to the negative 9 coulombs. And that is the final answer.